Using completing the square to find vertex form. So the steps here are a little bit different than regular completing the square because we're at f of x equals. So what we do is we put the ax squared and the bx in parentheses and the other number outside the parentheses. Also the same as last time, we divide the b in half, square it to create a new c term, and then we need to add the c term inside the parentheses. But because I'm not doing it to both sides of the equation, I simply add it inside but subtract outside, and you'll see what I mean in a second. And then it's easy to factor after that. So let's go through this and it'll make a lot more sense. Okay, we have the function f of x is equal to x squared plus 16x minus 12. And what we want to do is put it into vertex form. So step number 1, put the ax squared plus bx inside parentheses. Just that simple. Step number 2, the a term must be 1, and our a term is 1. So we can move on to step 3. Divide the b term in half to create a new c term. So I'm going to take the 16 and divide it by 2. That gives me 8 squared, which is 64. Now this is the weird part. We take the 64 and we add it inside the parentheses, plus 64. But because I can't add anything to the other side of the equation, what I do is I add it inside the parentheses, but subtract it to the outside of the parentheses. So 64 take away 64. I didn't actually change anything on that side of the equation, but what I am doing is creating a perfect square inside. What that gives me is a perfect square inside. Now I can factor that, and just like before, I don't have to worry about factoring. The factor is always going to be the middle term here, or it's the b divided by 2 if you want to call it. That's always going to be my factor, so you never have to worry about factoring. Now my function is in vertex form, and with it in vertex form, I can answer some other questions also. I can answer the questions for the y-intercept, the vertex, line of symmetry, and all of the things that we did back when we were graphing. Our vertex is going to be -8, -76. The domain is always the same, all real numbers. If we're looking at whether this is a minimum or a maximum, we have a positive a value, so this will be a minimum at the lowest point, which will be our y value of the vertex. Since the graph is going to go up, we can say our range is y greater than or equal to -76. Our line of symmetry. Our line of symmetry is always the x value of our vertex. It's a line, so I use the line equation, x equals -8. Next, the zeros in the y-intercept. Well, we were just working on completing the square. The zeros are when the y value is 0. So let's go ahead and solve this. 0 is equal to x plus 8 squared minus 76. In order to get the square on one side, we add the 76 to the other side. Now I have a square. I can take the square root. That gives me x plus 8 on one side. And on the other side, we have a positive and negative. 76, we need to break that down. So we say 76 breaks into 2 times 38, and 38 breaks into 2 times 19. We have a pair of 2's that can come out. So I have 2 square root of 19. Now I break this into 2 separate equations. And for both equations, all I need to do to solve is subtract the 8 to the other side. So I'm going to have zeros at -8 plus and minus 2 square root of 19. So those will be my zeros. Now to find the y-intercept, we set the x equal to 0. So you'd say f of 0 is equal to -12. So our y-intercept is at x was 0, y is negative. And we've not only put the function into vertex form where we can easily graph it, but we've also solved all of the important pieces of the graph. Okay, one more, a little faster this time. Step 1, put the ax squared plus bx in parentheses. Done. Step 2, the a term must be 1, factor if needed. So I'm going to go in here and I have a 3x squared minus 18. That means I have a GCF of 3. So I take out the GCF. That gives me 3 parentheses x squared minus 6x plus 7. The 3 is on the outside. Step 2 is finished. Step 3, divide the b term by 2 and then square it to find the new c term. Step 3, I found the new c term. Now I need to add that to both the inside and the outside. Again, this is the tricky part, and you'll see why in a second. If I add 9 to the inside that parentheses, am I only adding 9? The answer is no. I'm adding 3 times 9. If I was to distribute the 3 through, I would also distribute it down to the 9. So what am I actually adding to the inside? I'm adding 3 times 9 is 27. Whatever I do to the inside, I need to do the opposite to the outside. So I'm subtracting 27 from the outside. Just to make it clear, I added 9 to the inside. 3 times 9 is the same as the 27. So I have to subtract the 27 from the outside. That gives me a new function of. Now I can factor it. Remember, that middle term is always going to be this middle term, our b over 2. And we've used completing the square to find vertex form of the function. But why stop there? Let's go ahead and solve everything else. First off, the zeros. I find the zeros when the y value is 0. So we plug it in. Now when solving for x here, the steps are very important. Remember, we're going to do PEMDAS backwards. PEMDAS backwards. If we're doing that backwards, the first thing we're going to do is add the 20 to the other side. Now we can divide both sides by 3. Now we have a perfect square on one side. So we can take the square root and break it into a positive and negative. Now, right here, I hope that something deep down inside is telling you, wait, something is wrong. And you're right, something is wrong. Can you ever have a radical in the denominator? And the answer is no, you can never ever have a radical in the denominator. So now we get to review rationalizing the denominator. Well, in order to get rid of a square root of 3, I need to multiply it times another square root of 3. That gives you a square root of 9, and that gives you 3. If you don't remember rationalizing the denominator, please go back and review. What that gives me is x minus 3 is equal to the square root. 20 times 3 is 60 over 3. And the same thing for the other one. Before I go any farther, can I simplify the 60? And that gives me x minus 3 is equal to 2 radical 15 over 3, and the same thing on the positive side. Now all we have to do is move that 3 to the other side. And those are our zeros. Our zeros are 3 plus or minus 2 square root of 15 over 3. The y-intercept. Well, we know that the y-intercept is when the x value is 0. So we plug it in. G of 0 is equal to 3 times 0 minus 3 squared minus 20. G of 0 is equal to 3 times 9 minus 20. 3 times 9 is 27. 27 minus 20 gives me 7. So our y-intercept is at y is equal to 7. Our vertex is at positive 3, comma, negative 20. Remember, we always use the opposite number. Our line of symmetry is at the x value. X is equal to 3. Our minimum or maximum, because this is a positive a value, we have a minimum at y is equal to negative 20. The domain is always all real numbers, and our range is going to be y is greater than or equal to -20 because it goes up.